All right, everybody, let's do lesson 6 of our science unit. Two more to go. All right, so as I've started the last few lessons, let's talk about what an external force is. As if I'm sure you're sick of hearing me say, it's a force that is applied on an or on a structure by something else. That's basically what it is. All right, so given that, what do you think an internal force is? If an external is from something else, then an internal forces are forces applied by one part of a structure on another. They're forces that happen within a structure. All right, and I've got some examples here. Well, there's the same thing here again. I've got some examples here. So, compression. It's a force that squeezes or pushes parts together. Think like this hand squeezing an orange, right? It's squeezing it, right? And yeah, you could say the hand is acting on the orange, which is true, but the skin of the orange is acting on the inside, and the outer part of the inside is acting on the inner part of the inside, and it's all this squeezing going on inside the orange. All right? Tension is a force that stretches or pulls apart. So we got these two guys pulling on a string in opposite directions. So this part of the string is acting on this part of the string, this part of the string is acting on this part of the string, and it's this idea that there's a stretching force going on inside the string. Shear. Shear is a weird one to kind of understand. It's a force that pushes parts which are touching in opposite directions. So like these scissors on the band, right? So the scissors cut the the band, and one part of it goes up this way. When you picture yourself cutting it with a pair of scissors, one part will go up this way and part goes down that way. This idea of shear is that one side will go up and one side will go down. And torsion is a twisting force. So like wringing out a towel or turning a screw, right? This idea that there's some twisting going on. Complementary forces are when two different internal forces act on a structure at the same time. So here's our example, right? Here we have compression because the ocean floor is pushing on the bottom of this tower here, and gravity is pushing down on it. So the top and bottom are being pushed together, and that's our compression, this idea of pushing parts together. In this one, we have tension because this part of it is pulling on this side, and this part of it is pulling on that side. So we have tension pulling apart. Again, we have tension here between this rope and the base of the bridge, right? These arrows that are pointing in opposite directions show tension, and these ones that are in the same direction show compression in this suspension bridge. That's next time. All right, your task for today. One nice page here. So for each of these, I want you to tell what internal force is being described. All right? So compression, tension. So compression, squeezing, tension, pulling apart, shear, pushing in opposite directions, and torsion, twisting. Right? Shear, anytime you're talking about like ripping something or cutting something, is probably going to be shear. Right? Go through for each one of these. So stretching an elastic band, well, you're not pushing together, you're pulling apart. So what's that going to be? Right? Go through, answer all those. The second one, which two complementary forces are at play when you bend a plastic ruler? So think about bending a plastic ruler. What two of those four are happening? Is there compression? Is there tension? Is there torsion? Is there shear? Which of those show up when you bend a plastic ruler? Not breaking it, just bending it. So, when you have cars going over a suspension bridge, I want you to list external and internal forces that are there, and also draw a diagram, right? You have cars going over a suspension bridge. If you look back to the note or pause the video, you'll see there's a suspension bridge there, and that tells you basically all the internal forces. And there's a couple external forces I could think of, plus a few more that you could add in. All right, list them here. Draw a little diagram that has arrows showing where the forces are what direction the forces are going in. Once you do that, you're done. You're good to go, and you can prepare for the last little bit of this science unit. Until next time, take care of yourself and have a good day.